Alrighty, so I wanted to do example 2 prime where I changed the x from a 0 to a 1. I wanted to do that in Sage to show that we can kind of, do all our steps, but then cut through all the nasty calculation. So we had, I need to tell it I want to make x a symbolic variable, and then I made x1 and y1 1 and 2 just in case I want to go change them or something like that. I put in my function f as 4 minus x squared, and I defined that uppercase D as x1 minus x quantity squared plus y1 minus f of x quantity squared. And then I said show D, so I'll evaluate. And I commented out these with the asterisk or pound signs or hashtags. And so there's my x squared minus 2 squared and my x minus 1 squared. So it put things in a different order, but there they are. Okay, so now I need the derivative. So I'm going to call it dp for d prime equals, and I'm just going to say d dot diff, and if I ever get any of these commands wrong, I'll go try to look them up, but I think it's just diff for differentiate, and I had to tell it with respect to x. Now x is the only variable in there, but it's always good to tell it. And then I'll show that. Show dp. And evaluate. And so there we are. That looks familiar. I've got the 2x minus 2. Bring down the 2 and multiply through. I get 2x minus 2. Bring down this 2. And then also multiply by the 2x. And there's a 4 and an x there. And so it has my derivative. Now I want to set that derivative equal to 0 as we did before, but I'm just going to put in here dp. Solve dp equals 0, double equal sign for that, and then let's show that. And as I remember, we should have something like 1/2 plus and minus the square root of 3 over 2, and negative 1, I think, were the answers. And yep, so 1/2 minus square root of 3 over 2, 1/2 plus the square root of 3 over 2, and negative 1. Okay, so there are those. Now I can take a second derivative, dpp, and that is equal to dp dot diff with respect to x, and I should probably show that so I know what my answers are. Whoops, not s, dpp, and I evaluate. And there's that 12x squared minus 6 that I'd gotten. This is much quicker than what I did by hand, right? So there's my second derivative. Now here, yeah, we do have to get a little fancy. So notice I've got these 3 solutions, but how do I get at them? Well, okay, we'll do a show to show what we're getting here. So I start with S, okay, because that was the solution. Now, notice there are 3 components inside this bracket. So if I want the first one, I just use a bracket. Now you'd think I'd use a 1, but actually their numbering starts at 0. So the very first one is the 0, 1. So if I do that, notice then when I evaluate, I should only get, see, that first one. But now that's not quite what I want because it's x equals. Now, so that's an equation. Well, actually, you can tell Sage you just want the right-hand side of the equation by doing RHS with some open parentheses. And so now, there we go. So there I've got it, and I can put it into my DPP to see what I get. Okay, but now how do I do that? Well, you have to substitute it in, right? Oh, substitute. Well, let's try that. DPP dot. Now, I can tell you, I believe it's just subs for short. What do I want to sub in? I want to sub in this. And actually, I do need to tell it x equals this. So I said I just wanted that, but now that I'm thinking about it, you know, this might work if I just ask it for that equation. So d double prime, substitute in x equals, you know, this thing. So let's try that, see what it comes up with. The worst that'll happen is it'll yell at me and say it can't do it. No, it does it just fine. Now, but the problem is I don't know if that's positive or negative, just looking at it. So I can get a decimal just by putting a dot n, and again, open parentheses. These are all functions, and functions usually need open parentheses as part of their name. So I evaluate. It's negative. Okay, so that first one, second derivative is negative, concave down. So that was a relative max. And here I can put in a comment that says, oh, relative max. So I remember. And now I am going to highlight that, do a Control C for copy. Whoops. And hit enter, Control V, Control V again. So now I'm going to make two copies, make a 1 and a 2, and evaluate both of those numerically. And I see, yep, they are both positive. So concave up. So here is a relative min and a relative min. So which one is smaller than the other? Well, I will show D with that same substitution. So I will copy this part here again with a Control C and Control V. So I've got that one, and then I will copy that and Control V, and there's the other one. And so I evaluate, and 0.15, that's the smaller of the two, the 0.15 and the 5. And so this, I'll put a comment, appears to be the minimum. So there we go, and I can get that X and Y. Now, so I've got the X value, but I don't actually have the Y value. I looked at D squared, and so I need the square root of this thing. And so I could always go back here and just say I want the square root of all of that stuff. Now actually I can do the square root here and close it off there, and then do the numerical. or I can do the numerical part first and then close off the square root. Now, I guess theoretically, right, it should be better to keep the exact answer as long as possible, and then just to compare the two. I'll do the square root of 5 here with the square root, and again close that off in there and hit evaluate. So there I get 0.389, or about 0.39, and 2.236, and so that is my minimum value, and I've got my x back here, and so I could show then, so the right answer is the S1. Now what I'm going to try to do is try to make it fancy here. So I'm going to do a single quote and an open parenthesis, then single quote. So that should print a parenthesis. Then I'll put a comma, and I don't want subs, I just want this thing, Control C. I can type it in, but I like copy and paste. And then I just want the right hand side for sure this time. So there's my value. Then I want to print a comma. So I put that in single quotes. I think double quotes would work as well. And then I want that value I just calculated, so this square root of that, Control C, and put that in. Now, and if I do that, I didn't put the dot n on the end, I'm getting the exact answer. And then I'll close it off with a parenthesis. So there's my parenthesis, and close off the show. So I think that will print out my solution very nicely. Now the parentheses look stupid because they're really small, but and there are actually ways to fix that. I don't remember them off the top of my head, but there we go. There is the answer in all its glory, and I would definitely have not come up with all of this stuff over here very easily. We were on our way, but boy, that was a pain. And so this, I can do that problem in Sage, and doing that problem in Sage this way is not a problem. Now, I really should also back it up with a nice graph. You could graph all this stuff in Sage, but in the end, the Desmos graph is just so nice that I probably I probably would get rid of that. Just show my function here, f minus x squared, and show the 1, 2, and show my answer here of the 1.366, and get that way, right? And again, if you needed to show the 1.366, you could do a numerical thing on something like this. I could do a dot, and I could just copy and paste and do this thing twice, once symbolically and once numerically, and come down here, and there's the 1.366, and so forth. So there we go. Example 2 prime again, but done with Sage, and I will I guess try to copy this code and maybe attach it next to the video. So there we go.